Michio Kaku, The God Equation, The Quest for a Theory of Everything. Welcome to the world of The God Equation, where physicist Michio Kaku takes us on a fascinating journey through scientific history in search of a unified theory of everything. In this book summary, you'll explore the early theories of Aristotle and Democritus, the groundbreaking work of Newton and Maxwell, and the revolutionary discoveries of Einstein and quantum mechanics. Delve into the mysteries of black holes and the potential of string theory as Kaku brings us closer to understanding the deep, beautiful order of the universe.
Foundations of Physics. The origins of modern physics can be traced back to early Greek philosophers who attempted to explain the nature of reality. However, it was not until the 17th century that scientists like Johannes Kepler, Galileo Galilei, and Isaac Newton began to unravel the underlying order of the universe. Newton's laws of motion and gravity, as well as James Maxwell's equations for electromagnetism, provided the framework for all our modern engineering feats. While these theories were incredibly accurate, they were later complicated by another thinker in the early 20th century. Einstein and the complexity of physics. Einstein's groundbreaking discoveries reveals the limitations of Newtonian physics. His theories of special and general relativity reveal that the speed of light is constant. Time, energy, and space distort depending on an observer's frame of reference. Additionally, gravity is not a force but an effect of a curved spacetime fabric. Though experiments have confirmed these counterintuitive theories, they couldn't predict the tangled science of quantum theory. Einstein's contribution stands the test of time as he demonstrated the complexity of physics. The strange world of quantum mechanics. In 1910, Ernest Rutherford discovered that atoms are not as solid as previously thought. Quantum mechanics governs the tiny subatomic particles which behave weirdly. While classical physics laws predict outcomes, quantum laws deal with probabilities. Electrons, for instance, behave like waves, but we can only guess their probability of being in certain locations. The uncertainty principle, first elaborated by physicist Werner Heisenberg, sums up this peculiarity. The famous Schrödinger's cat experiment illustrates this principle. Einstein even found quantum mechanics preposterous, but its accuracy led to many scientific discoveries, including antimatter, DNA, and atomic bombs. The search for the God equation. Physicists have identified the four fundamental forces that govern our universe. These forces include gravity, electromagnetism, strong force, and weak force. However, understanding each force in isolation is not enough to comprehend the workings of the universe. Scientists believe that a single theory, commonly referred to as the theory of everything or God equation, unites all four forces into one comprehensive system. While many scientists have attempted to solve this elusive puzzle, no one has come up with a workable solution yet. The Standard Model is a theory that brings us one step closer to understanding everything. This theory has been developed by hundreds of scientists, who used particle accelerators to examine subatomic particles like quarks and leptons. The Standard Model aligns quantum mechanics and strong and weak nuclear forces while describing the physical world with a high degree of accuracy. However, it contains many unknowns, such as mysterious constants and a lack of accounting for gravity. Regardless, it remains one of the most significant achievements in physics, having predicted the existence of the Higgs boson, a vital elementary particle, and its subsequent discovery in 2012. The mysteries of deep space. Journey 53 million light-years away to the galaxy M87, and in the center, you'll find a gargantuan entity, a black hole 5 billion times the mass of the Sun that can consume anything that comes near. Black holes were once thought to be a dead end, but careful investigation has helped physicists realize that deep space is an excellent environment to test new theories and refine current ones. Cosmic microwave background radiation, CMBR, a remnant of the Big Bang, suggests that quantum mechanics played a crucial role in the universe's formation. However, many questions about the universe, like the role of dark energy driving its expansion, remain unanswered. By studying the quirks of these bizarre objects and other cosmic anomalies, physicists can refine our current theories and push them to their limits. The potential of string theory. String theory has the potential to solve the incompatibility between Einstein's theory of gravity and quantum mechanics. The theory proposes that subatomic particles emerge from the vibration of strings, including the graviton. String theory reveals symmetry and cancels out difficult mathematical components. It also requires the universe to have more dimensions. However, the theory has not been experimentally confirmed, and its abstract nature is a cause for criticism. Despite this, many scientists consider string theory the most promising model yet. Einstein's concept of God. In his later years, Albert Einstein, a scientific celebrity, received a constant stream of fan letters that asked if he believed in God. Despite not believing in the biblical God, he believed in the beautiful order described by philosopher Spinoza. This orderly universe could be fulfilled by a theory of everything, which would reveal a profound and elegant way reality is organized. At its core, a theory of everything raises many deep, philosophical questions, including the elusive force that put physical laws in place. While a physical model may unlock technological breakthroughs, it wouldn't change much in one's day-to-day life. Instead, a theory of everything would reveal that everything in the universe, no matter how small or vast, is governed by a single order. For some, understanding this order is the closest to reading the mind of God.
As we reach the end of this captivating summary, you have witnessed the incredible progress science has made in unraveling the enigmatic order of the universe. From Newton and Maxwell's establishment of modern physics to Einstein's revolutionary advances in understanding space and time, each step paves the way towards the potential of a unified theory of everything. Venturing into the depths of quantum mechanics and searching for clues within the vast cosmos, we stand at the cusp of discovering the true nature of reality. Yet, the deeper we plunge into the unknown, the more profound questions arise. Encountering the mysteries of the first mover and the tantalizing possibilities of a vast multiverse, our pursuit of comprehending the intricate order of the universe only perpetuates the eternal search for knowledge.